Hey, this is my solution to CS50's readability problem, and yes, it works. Let me show you. But instead of just showing you the final code, let's focus on how to think through the problem and build the solution step by step. Before we write any code, let's understand what the problem is really asking us to do. I've created a flowchart that breaks the problem into small but meaningful steps. You can pause the video here and try to build your own solution or follow along as I walk through each step and show how it translates into code. Let's get started. First, let's get input from the user. This text will be used to calculate the number of words, letters, and sentences. We are using the getString function from CS50.h library to get input from the user. For the next step, let's count the letters. We have created this function to count the number of letters. The function receives the text as its input and uses a for loop to go through each character of the text. Then we use the isAlpha function that we get from the ctype.h library to check if each character is an alphabet, and if it is an alphabet, we increment the counter by 1, and the function returns a counter. Now let us declare the prototype of our function. Let us open our code, call our function, and pass on the value of text. This will be an int called letter number. Here we have to also include the string.h library for our string function to work. In this way, we ignore spaces, punctuation, and numbers. The next step is to create a function that will count the number of words. Let's name it word counter, and it also takes in this text as an input. Now, this is where things can get a little tricky. Why? Because words are usually separated by spaces. Punctuations may appear after a word. Punctuations can also appear inside a word, like apostrophes. So instead of overcomplicating things, we will follow a simple rule. Count a word every time we encounter a space, then add one extra word at the end. Why? Because the last word doesn't end with a space. We're going to implement it using this function. Here, word counter accepts the string as its input and uses a for loop to iterate through each character of the string. If it is blank, or if s is equal to I plus 1, s stands for stirlen and I is the counter. This would be the position of the last character of our string. During these conditions, we will update the counter by 1. And with this, we will get the number of words in our input. Let's declare the prototype of our function at our code. And let's create a variable called wordNum, call our function, pass on the value of text. Let's count this number of sentences. For this, we're going to use a similar code. We know that sentences end with either a full stop or a question mark or an exclamation point. And we are going to iterate through our string, and we are going to use this to update the counter on the number of sentences. Similar to the other two functions, we are going to use a for loop to iterate through each character of our text. We are going to increment the sentence counter by 1 if we encounter a full stop, question mark, or an exclamation mark. Now, let's declare our function. We've declared our function, and let's call our function. First, initialize a variable called sentenceNum, and let's call our function. Pass on the value of text as input, and that's it. The next step is to find the value of L and S. L is the average number of letters per 100 words. So it's going to be equal to letter num multiplied by 100 divided by the number of words, that is word num. Now, S is equal to the average number of sentences per 100 words. So it is going to be sentence num multiplied by 100 divided by word num. Now, we plug L and S into the Coleman Liau index formula. Used to give an equation. We are going to use a float for this index float variable, because for the value of index float, we want to receive a much more precise value. and int will not give us a value consisting of a decimal point. Let's create a variable called index. Before that, let's include the math library. Let's round off the value of index float. And with that, we have our index. Finally, we can classify the reading levels. To classify the reading levels, if index is less than 1, it is going to be before grade 1. If index is greater than 1, and if index is greater than 1, but it is less than 16, it's going to be grade %I, index. And if it is more than grade 16, it's going to be grade 16 plus. Now, let's see if our code functions well. It does. Let's enter a text. Okay, it's functioning well. Let's check 50. And that's it. Our solution is complete. More importantly, I hope this video showed you how breaking a problem into small steps makes even complex tasks manageable. I'm on a learning journey, teaching myself programming and emerging technologies, and these videos are my way of staying accountable. If you're on a similar path, consider me your accountability companion. Let's learn and build cool projects together. I'll see you next time with a solution to CS Cypher. Thanks for watching and have a great day.